check the description below because I've written the timestamps for the different parts of this video, so you can skip to the part that interests you the most. I'm Tom Robertson, a programmer and video game designer. I worked in the video game industry for 11 years before I decided to be an indie game developer. I started out in 1997 making shareware games. I made top-scrolling shooters and puzzle games. I made a Pokemon knockoff called Battle Pets. In 2003, I made a primitive MMORPG called Blade Mistress Online. In 2010, I made a multiplayer co-op space game called Artemis Spaceship Bridge Simulator, and it's been my most popular indie game ever since. Well, what are these tutorials all about? Well, I recently did a self-evaluation and made a list of almost 20 different video game algorithms that I understand very well and can implement very easily. I discussed it with my peers who suggested that people might like to learn from me about these various algorithms. So I'm making tutorial videos for each of these video game tools in the hope that game programmers and indie video game devs will find them useful. These tutorials do not require that you know C++, but you will have to know how to program and understand game development. These tutorials are not for beginners. They are for coders and devs and will address specific algorithms and techniques. Dragging and dropping icons, shuffling around an inventory of items, a paper doll in an RPG. How does that work? This tutorial will discuss my solution and implementation. Here we are looking at Microsoft Visual Studio. You can see my C++ code and my application that is going to test this. So let's get into seeing what this particular application does. I'm going to go here. As you can see, I've got a bunch of icons and a bunch of slots. I can move these icons from slot to slot. Let me sort this. As you can see, there are different sorts of icons, and there are different slots, and there are more slots than there are icons, yada yada. The important part is what I'm doing with my mouse. I am moving things around, adjusting things, dragging dragging items from slot to slot. All this is just artwork. The slots don't have to be circular in any way. They don't have to be a particular size. In fact, the code is particularly flexible that way because, I don't know about you, but I fully expect that when I build a system like this, dragging items from slot to slot graphically, for any game I build, that the inventory space, the slots, whatever have you on the screen, are going to be changing size. The inventory box, the bits where you drag things to and from, that's always very dynamic in a game. So when we look at the code, we'll see why that dynamism is built in. But again, as you can see, the point of this is simply dragging and dropping. Now, you may say, well, I have an engine called Unity, or I have an engine called Unreal. I get the system for free instantly. And that is great. There's a lot going on under the hood, though. And while it may be very easy to drag and drop little blue circles, what if you wanted to drag and drop complex rectangles with lots of text on them? And how do you do that? Well, let's go into my code and we'll talk about it. All right. Let's get a nice expansive look here at my code space, where I start by defining some stuff that's important for this demo, which is to say I defined a cell structure, what each individual square or drop spot is, at least its values that define it. And also, I'm holding on to a bunch of pointers for the various images of the various pieces of artwork. Um, and then here's some extra stuff like the actual data of the top and bottom array of cells and a few other things, the dragging and hot and things. All basically just, values for this particular app. Two very important functions, which we'll dig into a little later, is mouse over and draw icon. And then here's my state machine for doing user interface screens or states, as you will. And this particular state machine gets called in four different situations. Once when it begins operation, once when it ends operation, once for every tick, that is for every time step, and once for every draw. This is definitely a draw. So what we see here is fundamentally what I would describe as immediate mode programming. If you have been programming in Unity, if you have been programming in Unreal, if you have been programming in GameMaker, if you have been programming in several other systems, including, of course, many of Microsoft's existing enterprise systems, then you have been programming in something which I call retained mode. So, what's the difference between immediate mode and retained mode? It's a philosophical concept of who gets control of your system. And there are very good reasons why you would want a single monolithic piece of code to control major pieces of your application, like, say, the screen, or, say, the keyboard, or whatever. And retained mode, the idea that there's a single manager handling something that you must appease in order to get your work done, is darn standard. In fact, I would say that immediate mode, and specifically the philosophy of an immediate mode GUI, is heresy. Is a particular brand of outrageous boldness that I have been an eager evangelical of for 2 or 3 decades. But I don't overwhelm you with that. I am just trying to explain that if you are familiar with, and in fact, if you kind of grew up with retained mode systems, then you know that if you want to put an icon on the screen, you have to create an icon object and fill out its forms, fill it out with all of its information, and then submit it or register it with the central screen manager or whatever, or add it to the screen graph, or however you want to call it. You create it and you submit it, and because you created it and submitted it properly, it is now on the screen. And you can retain some information about it. Sure, you can retain a link to it so you can adjust its position or its color over time. And then, of course, when you don't want it to be on the screen anymore, you basically deregister it. You ask for it back from the central manager. Um, the other key structural aspect of a retain mode system is message passing. So somebody clicks on your button. Somebody minimizes or maximizes the screen. The user interacts with your user interface. What does your code look like to deal with that? Well, in a retain mode system, it's called a callback. It's called a hook. It's called a function that you provide, and more specifically, you usually provide it and attach it to the actual object. So you want to put a button on the screen. Well, you create a button object and you write some specific functions that are like called on click or on up or on hover, and you attach those functions in specific prescribed ways to the object, and then of course hand it off to the object manager so it appears on the screen. And now every time a click happens from the user to your particular button, your particular function called onClick gets called. And then you can write internal code You can write code in that function, that little callback function, that little hook, um, of what happens when somebody clicks that button, which is fine and dandy. And again, it's hard for me to believe that the vast majority of programmers in the world don't do that. I believe there is a better way, or at least I believe there is a different way, and uh, and that's what I call and other people call immediate mode, and they specifically do it in regards to immediate mode GUIs. But so a retain mode system. I'm blathering on here. Sorry. A retain mode system, you're going to see it'll have a strong central messaging pipeline. And it will also have strong central managers. And the way you work with those managers is you create objects and then register or hand off objects to those managers and then take them back or deregister them when you're done with them and you don't want them to be part of the system or part or on the screen anymore. That's a retain mode system. Um, I'm not doing any of that. Um, I'm just writing, code and doing it myself. And so instead of a bunch of different little hooks that only get called when specific things happen to your button, the system is giving me or letting me hook in two functions, a tick function and a draw function. And every single tick, every single time through the logic loop of the program, my function gets called. And every time the screen draws, my draw function gets called. And I just said functions, but in this particular case, this function gets called for both of those, but has an argument of whether it's a tick or a draw. And more specifically, in this case, there's also a pass in for the very first time this state gets activated, and the very last time the state gets activated. There's nothing there. So, hopefully that puts you in a better headspace for understanding the code that I'm going to show you. And remember, I was just showing you that this tutorial is really simple. Just got a bunch of icons on top of a bunch of spaces. I can click on those spaces, nothing happens, but if I click on an icon, I can click and drag it. I can drag it as much as I want. So, let's look at how that works. This enter, this is what happens at the beginning once. Obviously, I load up all the art. And obviously, in image array 0 is just that dark, uh, um, straight, single color background circle. And then I have 5 different icons. So load them all up here. I'm loading them and storing the pointer or reference to them in this array. And then I have a bunch of cells, which are the actual tables. Specifically, I have 2 tables worth of cells, a top cell array and a bottom cell array. They're both num cells long. And I'm just clearing out their offsets and setting their values. Okay, and I can exit. So let's talk about tick another time. And this is very interesting because in my way of doing things, it's in the ancient days, the idea was to do as little during the draw phase of a program as possible, except the actual drawing. And by the old days, I'm talking the 70s and 80s. Now, of course, we have more computer power than we know what to do with. And so the idea that you would do logic during the draw phase of a program is now much more acceptable. And that's why there's just not a lot of logic in the tick of this. And what is there, we'll get into, but it's not important in the big scheme of things. So let's do the draw. This loop and this inner loop is what draws each of the individual cells on the screen. Remember, this is called every frame. So every frame we're redrawing everything from a black screen. That's perfectly normal, especially in a 3D program. And the way I like it. And why? Because, well, we're living in the modern world where that's what normal computers can do. Then I set just a few variables, and I'm set cursor to whatever cell we're talking about so that we can use cursor for the rest of this loop, for the rest of the internals of this loop. And set a few more variables for positioning. And then we specifically talk about this cell and where we draw it on the screen. And I would like to point out, just for ease of functionality's sake, we're not only figuring out where we draw this particular icon on the screen, but um, we're also storing that data not in any temporary variable. We're actually storing it in the actual cell. And there's really only one reason for that, which I will get into later. If there were certain things we didn't do, we wouldn't have to actually store that information in the cell. Storing that much information in the cell is actually kind of wasteful. But again, we're on a modern computer. Wasteful is relative. Storing a couple of extra floating point values in every single cell of an array of cells is not breaking anybody's bank. All right. This piece of code says um, if we're not actually handling the top set of icons but handling the bottom set, let's adjust some of these values so that the top set and the bottom set can clearly be seen as being in different positions and different orientations on the screen. There are plenty of different ways to organize different draggable icon cells, and this is just one of them. And then, of course, after we're done with that, now we have the actual position of the icon we want to draw. Remember, we're looping through all of them and drawing all of them. And now we're actually taking into account offset, which again, I'll get to that later. And then here's a very important thing. We're basically saying, hey, is mouse over? Now that we know where the icon is, we want to know, is the mouse currently hovering over that icon or not? And obviously we're using our own in-house pre-made function to make that easy to read and easy to do. And if we're hovering, then we just do a couple things. We take cursor, which is a valid pointer to an icon spot, a valid pointer to one of our graphical icons, and we're assigning it to hot cell. Remember, at the very top, we assigned hot cell to null. So hot cell is just going through, and if we find that a mouse is hovering, hot cell equals the cell that it hovers over. And incidentally, we also adjust the color coefficient. The reason we're going to do that, of course, is so that when we hover over objects, the color gets a little darker as a graphical indication of the hover. Again, there's plenty of ways to graphically indicate that something has changed because the mouse is now hovering over this icon. I'm choosing to make it a little darker. It works for me for this particular application, but there are plenty of different ways to do it graphically. So now that we've actually determined if the mouse is over and we've got the actual position, then let's draw it. More specifically, let's draw the little gray circle underneath the icon. Whether there's an icon there or not, I still want to draw the little gray circle. And I draw it in the actual draw position of the cell. Icon scale, half color, because I want the underlying gray to even be darker than it is already. And at the normal layer. So one of the ways in which my game engine called PAX works is that for two-dimensional art, which is all this screen stuff, all the icon art and fonts and things like that, all the two-dimensional art has a layer value draw associated with it. That's because, have I just broken my own word? I've used a retained system. Well, retained is relative. What I'm actually doing is I'm not drawing the icon right now. I am waiting to the end of the draw cycle. I'm piling up all of my draw commands, where the little rectangle goes on the screen and what color it's in and what bitmap is supposed to be drawn, piling it all up in a big stack, sorting it, and drawing it all at once at the end. That's simply for an efficiency situation and it doesn't really mean much here, when I'm actually in the draw call. But it does mean that it allows me to assign a layer of different pieces of artwork, two-dimensional artwork, so that of course the higher layers, the higher numbers, draw after the lower layers and therefore draw over the lower layers visibly. Actually, yeah. Um, so when this one says normal 2D layer, that's actually, if I can hover over this for a second, it happens to be const 1000. So that's just a stand-in for the number 1000. And then this is 1000 plus 2, 1002, which is larger, which means this one is going to draw over this one always, simply because one's on a higher level than the other. I like it that way. However, you may yourself have a system or an engine that does not have that layering, in which case layering is implicit. Layering is um, what what the draw order is what the call order is. In other words, if you draw 3 over here and then you draw 5, because you drew 5 last, they are also covering over the 3. If you see what I'm saying, um, and that you can still work with that, and you can still work with the system. It just requires a little bit more thinking about which draw order you're doing. Um, I actually, in my last engine, I did not have this layer specification, um, but I did have a function that was called flush, which would take all of the all of the draws that I had done to that point and write them to the screen so that I could then continue drawing, secure in the knowledge that whatever I drew from that point was absolutely going to be on top of what I had previously drawn. And with that extra flush command and being careful about my draw order, I was able to get the same thing done. I was able to make sure that the things that were on top of the screen were on top, and the things that were underneath of the things were underneath under things. And this obviously is a big deal when you're talking about a complex 2D user interface. Um, so we're doing that a lot, and in this particular engine, we're doing it with the layer argument. The layer value is as an argument to a lot of draw functions, um, which works for me now. But again, if you're using a retain mode system, it's much more likely that you, instead of drawing an icon or calling the draw icon function, you actually created an icon object and you, among other things, assigned it a layer value, and then you registered it or added it to um, the the central screen manager, or sometimes they call it the screen graph, um, and then that central manager draws your icon. And then when you no longer want the icon to exist on the screen, you ask for the central manager to give it back to you and or deregister it. Um, so we're all doing the same thing, just slightly different ways. Okay, so I just finished drawing the underlying grade position of every icon on the screen. And then I say, well, if I'm currently clicked down and I'm dragging this object, then I want to draw its position completely differently. I want to draw it attached to the mouse pointer. And I want to draw it 2 layers up, because if I'm dragging, I want it to not be underneath anything else. Otherwise, if I'm not dragging it, if it is not an empty cell, in other words, it's one of the 5 icons and not the 0 icon. See, curve value is greater than 0, and up here at the top you can see 0 is the back image, which is not a real icon, it's just the background image. So here we are looking at this code. Go away, give me a little more space. My layer is normal, and except it's +1 in this case, and then I draw the icon at the normal position and the normal value. Why did I do this layer thing here? Well, okay, I'll come back to that. So remember, that is all part of a set of loops. So here we are drawing every single icon on the screen in a simple loop. And that's one of the kind of the powerful things about this system and about immediate mode GUIs is you want to draw 10 icons, loop from 0 to 9. We're done. Okay, we're not really done, but if to me it seems pretty easy. Okay, and after all the icons are drawn, and I would like to point out at this point that um, hot cell is now set to whatever the mouse is hovering over. We have these two functions, or not functions, just clauses in the code. And here we are starting for the check of the drag, and we say, is the pointer going down? If I'm clicking down this frame, is my hot cell actually, a thing? Am I hovered over something? Am I dragging something? If I'm already dragging something, I don't want to do this. So if I'm not dragging something, but I am hovered over something and I'm clicking on it, well then, it's time to drag. First off, I don't want to drag things that are not valid icons. If it's 0, then it's an empty square, so don't drag it. But if it is, then my hot cell now becomes my drag cell. Now my drag cell variable is the current cell that I'm currently dragging. In this case, in C++, it's a pointer. Could just as easily be a reference. Could easily just as be an index, especially if my inventory data is laid out as a simple single array. If for instance you wanted to set it up so that your inventory of your RPG character was 20 items, but then also the store that you might go to buy and sell items also had an inventory of 20 items, and also maybe the inventory of dead monsters that you can open the dead monster carcass, and voila, there's stuff inside is like 5. Then you could theoretically have a single array of objects that were 45 long. The first 20 is your inventory, the second 20 is the store's inventory, and the last 5 is the dead monster carcass inventory. Doing it that way, then drag cell here wouldn't necessarily need to be a pointer. It could just as easily be an index into that single array. What I'm saying is that drag cell is a reference, some sort of reference to the particular cell we're dragging. And what reference type that is not all that important. Is it a pointer? Is it a reference? Is it an index? It's whatever works best for you and your situation and your game. In this case, because it's C++ and I'm very comfortable with C++, I'm not afraid of making this drag cell a pointer. So, but it's still a reference to a particular cell. I've got it. It's now in drag set, and now we do just a little bit more. We've got drag offset. Why do I do this? Well, let me fire up the program. If I want to drag one of these items, say I'll drag this sword and shield. Okay, I'm going to click on it, and then I'm going to drag it. Now, I'm going to let go because I don't want to actually drag it somewhere else. I'm just dragging. But what's interesting and key is that once I click down, I could just assign this icon to the location of my mouse, in which case the icon would center around my mouse. But if you look carefully, I am going to grab way far on the corner of the object and drag the corner. And that allows me to actually drag the top corner, the bottom corner, whatever I want. It's all just handled by this little piece of code here, which determines the drag offset. What's the difference between where the pointer went down and where I draw the object? Well, that's my drag offset. And I'm just going to use that for the entire time I'm dragging to make sure that the grab is smooth and not snappy and things don't jerk around. Okay, but the real key here is this code right here. Check for start of drag. If I'm not dragging something, and you can see my mouse pointer, but I'm hovered over something and my pointer's going down, and this particular item that I'm clicking on is actually something and not nothing, then I'm dragging it. That's the key of that code. Now this code is a little more complex, but it's a companion. It's start and end of drag. And notice that it kind of happens one after the other in this order in the draw code. And that's, that works out that way. So this particular code simply says if my mouse is up, if not, my mouse is held down. So if my mouse is up, we've got this clause here, but even if we ignore this clause, drag cell equals null in dragging. So this function is really simple, or this clause is really simple. It says if you're not clicking down, you're not dragging nothing. You're done dragging. There is no dragging. If the mouse pointer is not held down, no dragging. And also, if I'm dragging something, this is not, the mouse pointer is not held down now. If I'm dragging something and I'm hovered over some hot cell, and the thing I'm dragging and the thing I'm hovering are not the same, then do these things. So what this clause is basically saying, again, is that right now, if I'm not clicking on anything, drag cell is empty. Drag cell is null. It is not dragging anything. And if I drag something, but then I let go, well, it goes back to being null. So this particular code is specifically about what happens when you drag one item to another item, or one item to another slot, and you have to actually move the items around. So the fact that the items are actually kind of defined by the value means that swapping the values is easy and simple. The way to go. You just swap using a temp variable. Swap the values right now. So here I am in the code. I want to take this and go down here. Boop. So what did I do? Well, it looked like this thing actually moved from here to here. It didn't. What happened was this type of, say, 3 and this type of, say, of 0 because it's empty. That 0 and 3, they swapped. So this one is still this one. It didn't copy or move. It just went from a 3 to a 0. And this one went from a 0 to a 3. And then notice that I have this cool moving thing. So that when I actually swap things, they snap back to where they were nicely. Well, that's all well and good, and that looks nice, and we'll get back into how I'm doing that. But the important thing is this code. Here we are dragging. We're swapping the values. That's sometimes all you have to do. Now, in this particular piece of code, what I'm doing is, as the comment says, adjusting the offsets to the icon smooth to the. So each of these cells has an offset X and an offset Y. That's a draw offset, so that when I get around to drawing that hot cell, I can draw it using these offset X and offsets Y in a way that lets things be smooth. See, let's see, here's my position to draw is my draw X from the current cell, and also plus the off X. Now again, it snaps into position. It smoothly snaps into position. Why is that? Well, this is the why. If we go back to the tick function, then we loop through all the cells, and we basically take that offset X and offset Y and reduce it, multiply it, die down. And of course, this number, this 0.9, is a definition of how fast the thing snaps into place. If it is a lower number, it's going to snap faster, and if it's a higher number, it's going to snap slower. And of course, you never want it to go over or at 1.0, or it's going to get bigger instead of smaller. So it's a nice coefficient way of thinking. And also, this is kind of a smooth snap, which means that basically the farther away you drag the object, or the farther away the object is from the square it's supposed to be in, the faster it snaps back. And that looks nice. It has its own issues, but it looks nice. What I want to point out is that this is in the tick clause and not in the draw clause. Why is that? Well, most engines have the idea that there is a logic or a tick or a simulation phase, and then there's a draw phase, and that may be completely subsumed into whatever engine and or central manager you're using in your engine. But you should still be aware of it, and theoretically, most engines should make you aware of it. That the logic that happens for your objects in the world, how fast the rocket goes, should be disconnected from how fast the screen is updated. Why? Well, the basic obvious reason, which has been a problem for game developers for the entirety of time, is that if you hook your logic of movement or whatever into your draw phase, well, when your software goes over to another computer that's either drawing faster or drawing slower than your original computer, then everything goes faster or slower. And that's not what you want. You've already tuned your game to be the right speed. So you want your game to stay the right speed and for a rocket to take exactly the same amount of time to cross the screen, no matter what computer the game is running on, right? So therefore, there's a logic part that usually gets processed a very specific number of times per second. Certainly hope so. And then there's a draw part, which is theoretically going to go as fast or as slow as the computer chooses to go. And that is complicated by the fact, especially on PCs, with the idea that the PC has different resolutions and modes and full screen mode and windowed mode and whatever. And these can, for their own reasons, have different implicit frame rates. Um, so it's just normal. Your draw is not going to go at the same rate as your tick, which means that any actual logic involving movement over time or changes over time belong in the tick or the logic or the simulation portion of your code. This should not be news to anybody, I hope. But I do want to point out that some engines assume a variable tick speed as well as a variable draw speed. And in that case, those engines will always, theoretically at least, pass in a time delay value into the tick functions or into the places where your tick code, your logic code works, so that you can adjust the speed of your rocket depending on how fast the logic is going. Um, I wrote an engine years ago that did that. It basically had a tick function call that anyone participated in, and it had a single kind of universal value of time delay from last tick, which meant that each part of my code, if it wanted to move properly, it would take that time delay into account in its calculations, like this 0.9. But I found that that was actually more trouble than it's worth, and it's much, much easier to just simply force your tick code into uh, a very regimented time cycle. That actually just, I think, makes my code work a lot better and a lot cleaner, and I'm a lot happier if I'm guaranteed, say, 60 frames a second on my tick, or whatever it is I'm assuming. Which is kind of what this engine does. So, but at any rate, so that's a side thing. What I'm trying to say is that over time, and in this tick function, the offsets of my various cells shrink to zero. And that's how I get my nice smooth dragging and dropping to work. And even though here in the tick I'm actually changing it, I'm actually using the offsets in several other pieces of the code. I'm using it here to draw the icon properly. I'm not using that to draw the underlying gray position, just the icon that's on top, right here. Notice also this piece of code that I said, well, I want to draw an icon on the normal layer, but if you look at the code, what I'm saying is that if the change of my offset, or if the offset X and the offset Y is essentially a magnitude greater than 5, then I want to do layer plus 1. Why is that? Well, that's because If I grab an item, let's actually run the code and graphically show you. If I grab this item and I drag it over here, well, I let go of it, doo, it snaps back. But if I grab this and put it over so I'm actually going to swap these items, doo, then I get the nice drawback. Okay? Now you may ask yourself, how did I get here? Where is my nice car? That's a tiny little joke. It's a very, very old joke. Um, but you may ask yourself, if I'm doing this, why am I not beautifully snapping back? And the answer is I absolutely could, and it would not be hard. Um, but there's a principle of user interface that you often want to make sure the user interface does not go slower than your user, which is why this actually is a little bit slow. When you see these snapping, I bet the user would probably like it if these snapped to their locations a bit sooner. And that's an easy number to tweak. We were just looking at it at the tick section. But beyond that, of course, the idea is that um, whatever action I want to make sure it happens. It doesn't happen too slow for the user. And one of the actions that is really annoying for a user is if they cancel or take back their action and your user interface forces them to wait. So if I'm dragging this guy all the way across the screen and I let go because I'm like, I didn't want to do this. I didn't actually want to do any drags. Boop. Well, I actually just reset it to its point. But I could easily make its offset over here and then make it move smoothly back to here. I don't necessarily want my user to do that because then my user has to sit and wait, even that brief period of time, for my little icon to make its way back to where it's supposed to be. Um, I think just in terms of my experience in the video game industry, that is a little bit more tolerable to the user than the same thing dragging off to the thing, because the user is not doing anything here, but the user knows they're getting something done there, but they're not doing anything by letting go here, so they don't want to waste the time. it's it's not that we can't do the snapback in this particular case. We easily can, but from a game design point of view, a missed or bad snapback is kind of a user interface failure, my experience is the user doesn't want to wait around for that. But in this particular case, what we were talking about was this particular little piece of code that increased the layer. Let's talk about that real quick. Here I am putting this little thing out here, and I'm going to swap these two pieces. So during that entire time, you can see the piece flying all the way back across. Whee! And when it does so, if it is underneath any of these other icons, that's going to look weird to the user. The user's not going to like that. So make sure that while it's flying, while it's moving, it's actually higher than the other icons. And that's exactly what this code does. It says if the threshold of movement is greater than 5, then bump it up a layer. That's all this code does. Okay, so I stored where the mouse pointer grabs this icon. We've talked about that. We've talked about here in check for end of drag how I just swapped the values of the two cells, the hot cell and the drag cell. Remember, the drag cell is the thing you clicked on to drag it. The hot cell is the cell you're dropping the object onto. And here's the actual code that actually modifies the offset x and offset y, off x and off y. For drag cell, which is the thing you originally clicked on, it's just basically the draw x of hot cell minus the draw x of drag cell, and so on. So this is the one you clicked on. It's changing, and it's a little bit counterintuitive here, but this is the one that's going to move all the way from destination back to source. And then this one is actually offset from where the mouse pointer is. So this is the code that sets the hot cell off X and all Y. And again, if a pointer is not held down, no matter what happens here, drag cell is now empty, is now null. Okay, that's it. So let's look again at this code right here. Number of cells is equals 11, and we've got an array of top cell and an array of bottom cell. This is how, for this demonstration, I chose to organize the data of the various cells. But you can organize them any way you want. You can make any number of arrays. You can make one array. You can make several different arrays. You don't have to make them arrays. You can make them lists if you want to. The way that, especially if the list is going to expand over time, there might be a little bit more to it than that, but not much more. But the bottom line is your data should follow your game in this case. This stuff is much more universal. The hot cell and the drag cell and what they mean and how you use them, as well as drag offset, that's going to be no matter what, no matter how you define your cells, um, that's going to be the same. And speaking of defining cells, here I am dragging these icons back and forth, but there's an obvious utility in the concept of inventory. Um, we're not dragging cells for their own sake. In the games we're making, we're usually dragging cells so that we can put the +2 sword into our inventory, which means that this cell we have here is also going to be a +2 sword, or it's going to have a reference to a +2 sword. I think, unless your game is particularly complex and already has a particularly complex structure on top of it, it's fine for this cell to be a +2 sword in terms of the data that it holds. However, if you already have a +2 sword and you're already data, then maybe you should just add these things to your existing +2 sword item thing. In fact, all your items, everything that can go into an inventory and be drug around. And then what's happening is you've got offset X and Y and draw X and Y, which are just incidental values that get maintained by the code that I've just shown you. And in terms of drawing, you've got a very specific function here, draw icon, which takes an argument, right now a type, and draws the icon. Well, it could just as easily take the whole cell as an argument, or have as much information as it needs to properly display a +2 sword. And this draw is pretty trivial, but that doesn't mean that that's all that has to go into draw icon. You can put, and probably ought to put, a great deal of drawing inside the draw icon function, including the fact that it's a sword, the fact that it's +2. Draw the +2 as a numerical value, but also draw the sword as a sword icon. Um, Graphically speaking, it might be better to put, two lightning bolt icons instead of the word +2 or the text +2. You might want to show an icon bar for the wear or damage value of the sword. You might want to have indicators of color or style, depending, or because of what type of weapon the sword is, or where where the sword actually was made, or whatever. The sky's the limit, and the idea is that this is the place. And why this place? Because you wrap it all up in a bow in this draw icon function, and that allows, again, my code down here to simply use draw icon as to do its normal underlying work. So that's the point of all this. You get an inventory or a set of icons, or things that need to be adjusted, and you need a way to quickly and easily drag them around. Well, here you go. Very intuitive and happy, and it works with this code, which is a little bit of information, a couple of specialty functions, a little bit of ticking, and a significant amount of drawing, including these two clauses at the end of your draw, which specifically handle the mouse going up and the mouse going down. So now one would wonder, and I've talked to programmers who would wonder about why you would put any input logic like the keyboard or the mouse or anything of that nature in or the game controller, any of that logic inside the draw. And that does sound very, huh? It's certainly, way back in the day, that certainly was kind of the idea that if you're talking about real time and your tick portion of your code or your simulation portion of your code was running at the proper frame rate and everything, then it seems logical that you would handle the keyboard and the mouse, or sorry, the keyboard and the mouse and the game controller in that code. And that's true and not at all, uh, wrong. However, um, I am handling the mouse here in the draw code for two reasons. One is that philosophically and structurally, I actually think that the mouse really does tightly bind to the screen and the graphics for very obvious reasons, that the mouse is a very graphical user interface by definition. It's always a pointer, and if you don't have a pointer on the screen, you literally don't have a mouse. You can move your mouse all you want, but if you don't see it on the screen, it's a hunk of useless plastic. And also, whereas it's perfectly understandable that the user could press a key and then let go of that key faster than the actual screen frame rate of the computer, um, that's not how mice are expected to work, especially when it comes to moving. Um, so Plus, of course, what I said earlier, computers are not as slow as they used to be. It's not as much of an emergency to make sure that your draw cycle is as perfectly efficient as possible. I know we're still focusing on efficient drawing, but we're focusing on efficient drawing on a completely different scale. We're focusing on efficient drawing of making sure that we don't draw more than the several million triangles we're drawing per frame in a normal, AAA title. What's a mouse call compared to that? Um, so so that's why you see me interfacing with the mouse, my code, doing the mouse stuff in the draw cycle. It makes a lot of sense there, especially again, as I was saying, an immediate mode GUI thinking way of doing things. It doesn't have to be, it's just the way I'm doing it. Okay, so let me go back and have a look here. Good. I hope that you learned something. I hope that this was useful to you. Um, I will continue doing these tutorials. It won't be all about user interface and it won't be all about two-dimensional graphics. It'll be all over the place. It's because, again, these tutorials are not defined necessarily by what you absolutely need, but what I can do. These are tutorial of algorithms that I'm very comfortable with and have done several times, sometimes many times, and I consider them fairly trivial. So I want to share that algorithm and that efficiency that I've come to, and I hope it helps. um, Watch this space. Subscribe and hit the little bell for notifications of the next one if you want to. And I hope that you'll watch more. Thank you for joining me. Bye bye.